This is off the CUDA worksheet, the one that was just square roots. It's the first of all the series of them. Number 12 is a little confusing because you get the square root of 34. And if you go prime factor 34, 34, bless you, is 2 times 17. Those are both prime numbers though, right? So if I replace it with the prime numbers, can I get anything out of there? No, there's not 2 of anything that's the same. So this one doesn't reduce, so what you do is you just circle this, it's your answer, because you can't reduce it anymore. Or you could write doesn't reduce, but what we tend to do probably is just circle the term, and that's just saying, hey, that's as reduced as it gets. So if that one confused you, it's because it didn't reduce. So now we'll look at 13 was negative, square root of 127. Did anybody find anything that divided into 127? I think it's prime, but did somebody find something that I missed? I think this is a prime number too. It doesn't look like it should be to me. It looks like something should divide into it, but everything I tried didn't work. And I think I went through all the primes up through like 41 and 43. So I think this one is as reduced as it gets. If anybody found anything to divide in it, let me know, because sometimes you'll think something's prime and it's some prime number that you just forgot about, or it was so high you didn't try it, you know. So if y'all find something, let me know, okay?
Well, when I was doing it for Melissa, she used this table or whatever.
Yeah.
I was putting them into decimals and like.
Yeah, remember I told y'all we're not going to do that. See, one of the things, let me turn this off. Okay, so 13 didn't reduce as far as I could tell. If somebody finds something, let me know. 14, square root of 1. They didn't put plus or a minus out front, so I'm going to put plus or minus because there are 2 square roots of 1. What is the square root of 1? 1. 1 times 1 is 1, and negative 1 times negative 1 is 1. Okay, so 15 was the next one. Yep, that's a perfect square, isn't it? So we're going to put a negative because they put a negative out front. Negative 6 would be my answer. And then on 16, negative square root of 148. Now, I know that, yeah, let's do a factor tree. I can tell 4 divides into that, but other than that, I don't know. So I'm going to go ahead and do a factor tree. I know 4. The reason I know 4 goes into that, 4 goes into 100 and 4 goes into 48, so 4 would go into all of it. So let's see, 4 goes into 14 3 times, that would be 12. 4 minus 2 is 2, I'd have 28. 4 goes into 28 7 times. 4 was the biggest square, I just didn't know it. I thought maybe something bigger might work. So what I'm going to do, I could write this as a prime factor if I wanted to and say 2 2 37. Could I also have said 4 times 37?
No.
Because I could have said the square root of 4 is 2. Oops, again. So I could have put 2 times 2 here and said there's 2 2s, so they both get to get out as a pair of 2s, or I could have put the square root of 4 as 2. You kind of find a way that makes sense to you. A lot of people like that square root dance analogy if they're always going to prime factor. But prime factoring takes a little time, and if you see a perfect square in there, it's always faster to go ahead and do that because it gets the number so much smaller, so much faster, okay? So this would be negative 2 square roots of 37. I'm going to do one on the bottom just because we had 2 people absent. 17 through 22 they want to do?
17.
Okay, 17.
That's 1 half.
It is, and it would be, okay, so what you do when you have a fraction under a radical, you can either write it like this, or you can split it up and just take the square root of the top and the square root of the bottom. So if I'm going to put the negative out front because they put a negative out in front. The square root of 1 is just 1, and the square root of 4 is just 2. All of those there on that page that had fractions in them, they all reduce. Like look at 22, for instance. You might not have recognized the perfect squares there, but they were both perfect squares, right? Let's see. If I split them up like this, And they each get their own their own square radical, their own radical here. The square root of 196 is 14. I tend to forget that one. It was a hard one for me to remember for some reason. And the square root of 225 is 15. So the answer is negative 14 over 15. You just split them up separately. Okay. Any questions on that sheet? Okay. So these are a lot like what were in your book. They just, looked a little bit different because they're not putting the plus out in front like the book is. So on the first page, let's look at number 4. On number 4, on 4.32, they say you got a table to fill out. It wants to know the square, and the number is 199. It wants to know what's the square, and it wants to know what's the square root. Well, this is not fun because, you still aren't using calculators, which I'd kind of like for you to be able to, but I don't know. I don't think some of your parents want you to yet, so I'm going to kind of hold off. It's more one of those things. They'll be happy. Take this one because it was not fun. 9 times 9 is 81. Put down your 1, carry your 8. 9 times 9 is 81. Plus 8 is 89. Put down your 9, carry your 8. 9 times 1 is 9, and 8 makes 17. Now the next number is also a 9, so I'm just going to put down a 0 and then copy all those. Okay, so that's good. Yeah, and then you just need 2 zeros, and 1 times 199 is 199. So that's a 1. I'm going to have to write it over here because I don't have any room on the iPad. 1 in that column, a 0, carry your 1. So that would be 18. 18 and 7 is 25, and 1 is 26. Put down your 6, carry your 2. 9, 10, and 9 make 19. Put down your 9, carry your 1. I'm getting 39601. Is that what you had? Okay. 39601. Let's see what the book has. 39601. Yay! That's one you don't have to do. Now, the square root of 199. Oh, my. Let's do a factor tree. I don't know if 3 goes into that or not. I'm going to go for it and see. 3 goes in there 6 times. No, doesn't, does it? 7 goes into there. 2 times it'd be 14, but not into 59. 3 didn't go in there. 7 didn't go in there. It might be. See, these are hard because you think, what if there's some number I'm just not, seeing that goes in there? 5 won't go in there. 7 won't. 7? Does 7 go in? No, we already tried 7. 9 is not prime. Okay, so 11 doesn't go in there. 13. Does 13 go in there? 1 time 69. Does 13 go into 69? No. I think it's prime, so the square root, we would just say the square root is the square root of 199 then if it's prime. If you can't reduce it, we are not going to write it as a decimal. If you see directions that say extract the root, ignore it. We're just going to do it this way, okay, with the factor tree. Because we're not going to do that. That's dumb in an age of graphing calculators. Okay, so 17 says 12 is a rational number. Rational. If I do 12 is, the square root of 12 would be the square root of 4 times 3, which would be 2 square roots of 3. Any number that has this radical left is not going to be rational. So 12 is not a rational number. So if it asks you 12 is a rational number, wait a second. They say true in the book. I would say false.
I would say true.
Why would you say true?
So that's true?
The book is saying true, and I guess the reason it's true is because it's like 1.73208080, and the 8 O's repeat. So that's why they would say it's rational. Most teachers just go, oh, that's irrational. I've never really checked it to see if it repeated out that far. Okay, 18, 0 is an irrational number. If it's a whole number, it's rational. So 0 is kind of like a whole number, even though it's like,
Yeah.
so we'll say true. Oh, no, it's false because it said 0 is irrational, so that would be false. 19, the number 5 in square root of 5 is a surd. Yes, that's, now why didn't they tell you that in the book? They called that the index. No, they called that the radicand the other day. So another word for radicand is surd. That's why that's true. Okay? And again, that's one of those words you don't hear very often unless you're a math nerd into really proving things and you like all the vocabulary with math. I don't ever use that word, but I see it on Twitter sometimes where teachers are being really nerdy. Okay. 20. The number 16 in square root of 16 is a surd. Well, you would think it would be true if surd means radicand, but apparently surd doesn't mean radicand. So let's go find surd in the book. Okay, so it's here. Let me write this on the video. The radicand. So a radicand does not equal surd. The radicand it's basically that has an irrational square root is a surd. 16 if you take the square root of 16, you get 4. 4 is rational. Therefore, 16 would not be a surd. Okay, so the reason that we had a surd on 19 was that, what was that number? It was like 5. 5, the square root of 5 is irrational. It's not a repeating decimal, so it's a surd. But the square root of 16 is not a surd because square root of 16 reduces to 4. Well, that's nice to know. Is square root of 19 rational? No. Okay, not rational. So that one's going to be false. They said it was rational, so it's false. What they wrote is false. 22, the principal square root of 25 is 5. The principal root is basically the positive root. So is the positive square root of 25 5? Mm-hmm. Yes, so that's true. Principal root is the positive root. So that one actually is true. So if you ever see principal root, just think they just want the positive one. 23, the 3 in the cube root of 16 is called the index. That's true. So this is the index. That's true. When they don't write an index and they just write this, what do they want? Isn't that just the square root? There's like an invisible 2 because we use it so much they don't want to write the 2 all the time.